Assalamu students. Today's topic is going to be about tension in the string. Let us read about the tension in the string. Consider a block supported by a string, which is over here. The upper end of the string is fixed on the stand as shown in figure. Then W be the weight of the block, which is down here. This is W. The block pulls the string downwards by its weight. This causes the tension in the string. This is a string, and because the weight of the block is acting downwards, so there's a tension in the string. The tension T in the string is acting upwards at the block, like over here. As the block is at rest, therefore the weight of the block acting downwards must be balanced by the upward tension in the string. That means these two forces, this tension is also a force and weight is also a force, and they both are balancing or are in equilibrium with each other. That is why the block is not moving upward or downwards. Thus the tension in the string must be equal to or opposite to the weight of W of the block. Now let us consider this application in case of pulleys. Vertical motion of two bodies attached to ends of a string that passes over a frictionless pulley. Now let us define the pulley first. Pulley is that machine which makes our work easier, which has a round shape and the strings are going around it so that we can pull or push objects easily without any work actually being done by us. Consider two bodies A and B of masses M1 and M2. M1 is of yellow color, M2 is of green color respectively. Let M1 is greater than M2. As you can see in the diagram, M1 is greater than M2. The bodies are attached to the opposite ends of inextensible string. That means the string over here, it is not extendable. That means it can't extend just like a rubber band. So it is fixed. The string passes over a frictionless pulley as shown in figure. This is a pulley of red color. The body A, being the heavy, must be moving downwards with the same acceleration. That means as this is a heavy body, this will move down under the action of gravity, and this is a lighter body, this will move up because this body will basically pull the first body. Let this acceleration be A. At the same time, the body B attaches to the other end of the string moves up. Same acceleration. That means with acceleration which is pulling down, with the same acceleration, this body will move up. As the pulley is frictionless, hence the tension will be the same throughout the string. That means that if the pulley is not rusted or something, then these wires or these strings will basically have the tension same in this direction as well as in this direction. Now we have to calculate how much was the tension in the wire. First we'll name them. This is body B of mass M2 and this is body A which is of mass M1. Let the tension in the string be T. Now as the body rotated, as we can see over here, the body is rotating as we let go. So in this case we can say the heavy body basically goes down, whereas the lighter body goes up with some acceleration. With the same acceleration it is pulling up. So we can say this body, that means the body in yellow color M1, is greater than tension. That means how much greater? That means it applies a force of M1A. That is the force applied by this body. So M1G minus T is equal to M1A. That means this body is applying a force in downward direction, just like over here. In the same case, the weight of this body is less than the tension in the string. That is why it is moving in the direction of the string with the force M2A. That means the force of this body is moving in upward direction with some acceleration A. And the acceleration in these two cases are going to be the same because this body is applying the force and this is receiving the force in this opposite direction. Let the tension in the string be T. So we have to find out T. Since body A moves downwards, hence its weight is M1G. Is greater than the tension T, just like I told you. That means in this case, the tension is less than the weight of this mass of the block. That is why I've written M1G minus T, because m1g is greater than the value of T. The net force acting on the body A is equal to m1g minus T according to the Newton's second law. That means m1g minus T, it has applied some force and the body move in the direction of the force with some acceleration, which is the Newton's second law. So we put it equal to the Newton's second law, m1a. We call it equation A. Similarly, as the body B moves up, hence the weight of m2 is less than the tension in the string. Again, now in this case, the mass is less than the tension and the body will move in the direction of the force of the tension. Therefore, the net force acting on body B is T minus 2g. That means minus 2g is minus because this weight is less than the tension in the wire. According to the Newton's second law, again, tension minus the weight of the second body m2g is going to be the force applied on that body m2a. This is the force being applied according to the Newton's second law. When the force is applied on the body moves in the direction of the force. So the force in upward direction in this case, in m2 case, whereas the force is directed downwards in the case of m1. Now how can we relate these two in equation to find out acceleration, that with what acceleration they were basically moving from one place to another? We can add equation A and equation B. So this is equation A and this is equation B. We get an acceleration, that what was the acceleration by which these two bodies were basically moving. So we are adding the equation A, m1g minus T plus, because we are adding up like over here, plus T minus m2g, which is the left hand side of the equation B, is equal to m1a, which is the right hand side of equation A, plus m2a, which is the right hand side of equation B. Now in this case we see that 1t, the tension, is in plus, whereas 1t is in negative, so we cancel out this t. The t is being cancelled out. What we get, m1g minus m2g is equal to, we take a because a is common in both of these terms, so we take a as common right over here and we are left with this equation. In this case we can see the g is also constant. We will take g, the acceleration due to gravity, as common as well, like this. Now we can rearrange this equation and find out the value of a. So a will be equal to m1 minus m2 divided by m1 plus m2 into g. Just take m1 plus m2 to the other side, we'll get the value of acceleration. This is how we get the formula for acceleration of a body if it goes on a string around the pulley. Now to find the tension, we have to find the tension in the wire. We can divide equation B by equation A. So this is equation B right over here, and this is equation A. Now we are going to divide the two equations. So if we divide, let me clear this out. Yes. Now the equation B says T minus m2g divided by m1g minus T, which is on the left hand side of the equation of A and B, is equal to m2a divided by m1a, which is on the right hand side of the equation. We will cancel out this a, so it cancels out. We will cross multiply, this whole thing will go onwards, upwards, it will multiply. Onto the other side, this m1 goes to the other side, it will multiply. So it will be written as T minus m2g into m1a. For the time being, we have not cancelled out this value. So a is written as it is, but it can be cancelled later on like this, from here to here. Again, we can cancel it over here. We can cancel it here as well, no problem. Now, in this case, we have m1 into m2g and g minus m2g. And on the right hand side, we have m2 into m1g minus t. Now, we will multiply this m1 with t and we multiply this m1 with m2 as well. This is the multiplication technique. And in the same case, we will multiply this M1 with this M1G, and we will multiply this M2 with M2G. So this M2 M1G will be on both sides, and they will basically add with each other. How? Because we can see that it is negative over here, and when it goes to the other side it will be positive. So let us solve this one. So first of all, we multiply T into M1 minus M1 M2 into G is equal to M1 M2 G minus M2 T. Now taking T to one side of the equation and taking M1 M2 G to the other side of the equation, that means we are going to solve it. So it will be T M1 plus M2 into T, because this M minus sign when goes to the other side it will be plus, whereas this negative sign when goes to the side it will be M1 M2G plus M1 M2G. Now these M1 M2G and M1 M2G basically are taken as variables, so when two variables are same we can add them both in the case of terms, and taking T as common because T is present in this one as well as in this one. So T is common now. So it will be M1 plus M2 is equal to M1 M2 into G, because we added up these two. If we want to find out the value of T, we'll take M1 plus M2 to the other side. It will divide and it will be written as T is equal to 2M1 M2 divided by M1 plus M2 into G. This is the equation for the tension in the string when it was passing over the pulley under the action of gravity. Now let us change the scenario or situation. If we say the motion of two bodies attached to ends of the string that passes over a frictionless pulley such that one body moves vertically and the other moves on a smooth horizontal surface, then what had happened? The case and scenario totally changes. In that, let's consider two bodies A and B of masses M1 and M2 respectively, just like we did before, attached to the ends of an inextensible string. Again, the string is not stretchable as shown in figure. Let us show the figure first. This is the situation that one mass is attached and hanging under the action of gravity, while the other one is on a smooth surface on a table which is smooth, and they both are attached via pulley with the help of an inextensible string. So let the body A move downwards. Let's call this body A, and it is moving downwards with an acceleration A, because this body is heavier, we can see it. So it is moving downward with acceleration A. Since the string is inextensible, therefore body B also moves over the horizontal surface with the same acceleration. That means this body will also move, but not in downward direction, not in upward direction, but in the horizontal direction towards the force where it was applied. That means this heavier mass is pulling this lower or smaller mass. Now, since the string is inextensible, therefore the body B also moves along the horizontal surface with the same acceleration, as the pulley is frictionless, hence the tension will be the same throughout the string. In this case also the tension will be the same throughout the string, like over here, in this direction the tension in the string, and over here it is going to be in the opposite direction, putting it towards the center. Yes. Now, let us see how it goes. We are saying that this is basically mass A over here. We are saying that this is mass M1 at point A, position A, and this is mass M2 at position B. Now, we are going to solve in a similar method to before, that what is the acceleration in this whole case and what was the tension in this whole case. So as you can see in the animation, that as the time passes, the heavier mass will pull the lower mass towards the center, just like this. Now, the acceleration is in the direction of the heavier force. Since body A moves downwards, therefore the weight mg is greater than the tension T. in the string, just like in the previous case. The net force on body A will be m1g minus T. That means this mass or this weight is greater than the tension which was pulling it upwards. So we will subtract the weight uh, with the tension. So according to the Newton's second law, that means when the force is applied on the body moves in the direction of the force. M1g minus T, that means what direction the weight was pulling the block against the tension, it is going to be M1A, which is right over here. The arrow is showing the direction of the force the weight was applying on the string. Now, this is the equation for the first law. Now, if we want to consider for the second law, that means the upward force, which is the reactionary force R, let's say it is R, and the downward force, which is the weight, are basically balancing out. That means the body is neither moving upward or downward, so they cancel out. So there is no upward or downward forces. The only force it basically is experiencing is the tension in the wire, and which is pulling towards the pulley, towards the right hand side. Now we will study that in detail. The weight m2g of the body is acting downwards, which is basically cancelling out with the upward force, which is reactionary force R of the horizontal surface acting on the body in the upward direction. So one is in the downward direction, the other one is the upward direction, and they will cancel it out. The third force, which is the tension in the string pulling the body B horizontally over a smooth surface, as the body has no vertical motion, hence the resultant vertical forces M2G and R must be equal to 0. That means these two forces R and the weight of the string are cancelling each other out. So the overall vertical forces are 0, but the horizontal forces are still there. So how can we solve this for the horizontal forces? According to the Newton's second law, that means the only force which is applying on this body is because of the string, and which is pulling it towards the pulley. So it is the force M2A with the acceleration of this body which was pulling it downwards. So we'll say that according to the second law, T is equal to M2A. The body M2 will experience this much force M2A. Now if we want to calculate the acceleration, what we'll do, adding equation A, which is over here, with equation B, what do we get? So it will be m1g minus T, which is equation A on the left hand side, like over here, plus T, which is the only thing on the left hand side of equation B. Similarly, on the right hand side, it will be m1a1 plus m2a2, which is on the right hand sides of equation A and B respectively. So this T, let me clear it out a little bit. Let me show you the T, because it is negative, and this T, which is positive, cancel each other out because one is positive and one is negative. The new equation can be written as m1g is equal to m1 plus m2 into A. We have taken A as common because acceleration is same throughout. Now, if we want to calculate the value of A, we'll take m1 plus m2 the other side of the equation. What do we get? We'll get A is equal to m1 divided by m1 plus m2 into G. Let's put bracket over here. So this whole thing is multiplied by G, like this. Now, if we want to calculate the tension, for the same procedure, we will put the value of A, which we have calculated over here, in equation B, right over here, because acceleration we know now. Now, in this case, how do we can solve this equation now? Just by putting the value of A, we get, if we put the value of A, T will be equal to M1, which is over here, into M2, which is over here, right over here. We put the M2 over here because it is multiplying, divided by M1 plus M2 into G. Same case scenario, and we multiply with G. So this equation, T is equal to M1 M2 divided by m1 plus m2 into G, is the tension of the wire or the string when motion of two body attached to the ends of the string that passes over the frictional pulley, such that one body moves vertically and the other moves on a horizontal surface. So this is the case which we have defined over here. I hope you understand the topic. Inshallah, we'll meet again. Allah Hafiz.